Hello guys, welcome back to Data Forge by Piyush. In today's sessions, we are going to cover Spark internal working mechanism. So we are going to learn as soon as we submit the code how Spark behaves and each and every components how they behave or how they work internally when we submit our code. So let's go ahead for the day. So in this picture, you can see this is the real-time example of a Spark architectures, which we have covered in detail in our past video. So you can see here, this is the example of a family having dinner in a busy restaurant. So basically, family is the application or the client which submits the menu order, and driver is the service boy who is taking care of that family and collecting the orders from that and serving the food. Head chef is the cluster manager, while the chefs who are actually cooking the food are called the executor here. So you can see there are mainly three components: driver, cluster manager, and executor. So this all the things we have covered in detail in our past video. So we will see now in detail how each and every component works internally in depth. We have seen there are basically three main components in the Spark architectures: driver node, cluster manager, and worker node. So we will start with the driver node mechanism because this is the entry point of the Spark. As soon as you submit your code, this is the first point of contact where your code interacts with the cluster. This is responsible for all your designing of the code, how your code will work, how each and every line will behave, and what each and every line will processing of each and every line. That is why this is called the Spark of brain of the Spark as well. So let's start with this. Suppose the client submit its code into SQL language. One SQL language code of 3 line, 4 line, or multi-line code is submitted into cluster. So as soon as you click on the enter button, cluster creates the Spark session. This is the entry point of your code. So Spark session basically creates or reuse the available resources. Once this is created, your code moves into Catalyst Optimizer. As you guys know, Spark is basically developed into Java language. So Spark understands only Java byte code. But we have seen that we are submitting our code into SQL language. Then it will not be able to process your code or process your application. So Catalyst Optimizer works with the Java virtual machines, which converts your Python code or SQL code into Java byte code. Once your code is converted into Java byte format, it optimizes your code that which line will get executed first and which after that. So let's understand that part. You submit one unresolved logical plan. We don't know whatever the code we are submitting, how that is going to be executed. That means which part of the code is going to be executed first, which is going to be executed in a parallel, or which all activities are possible in a parallel, or which all needs to be executed in a sequential format. We don't know that thing. We only write the code and submit. That is called the unresolved logical plan. Spark reads that code, reads that line of applications and decide that what needs to be executed and what should be the sequence of the executions, or there is any possibility of parallelism and all. That is called the resolved logical plan. How your code is going to be executed. Once this is ready with us, there will be optimized logical plan. Optimized means we understood that there is a possibility of parallelism, or there is a need of caching of data, or any other kind of optimizations techniques, or there are possible. So basically, Spark understand that by reading that line of code and decide what needs to be executed and where. So it creates one optimized logical plan after using its internal optimization techniques. So whatever we give, that is fine. But other than that, there are certain optimization techniques available inside the Spark machines as well. So it uses those techniques and creates its own optimized plan. Once this is ready with us, it will create the physical plan. Physical plan is the actual code which is going to be executed inside the Spark. This is all what we were discussing. This was all kind of theoretically that this can be done, this can be executed here, or once, one, two, three, this can be the sequence, or this can be parallel and all. But physical plan is the code or planning of the code which is actually going to be executed. Once that physical plan is ready with us, it decides the best physical plan. A best physical plan is decided after the cost optimization. After the cost optimization, like with the minimum cost, how here best execution of code can be done. Once this is ready, it goes to the Spark context. Spark context basically is the available tools or basically available interaction between your driver node and your cluster manager. So what does it do? See, Spark context basically connects this cluster manager and request for the available resources. What all executors can you provide and how many because with the best physical plan we have decided. See, this is the best physical plan and it has all of this data that how many executor, how much memory, RAM memory, CPUs are required to perform your operations, to perform the execution of your code. This is what we have decided into our best physical plan. Now, once this is ready, Spark Context collects all of this data and decide and now based on the resources, it converts that data into resources format, like how many executors and how much RAM and CPUs are required. It connects with the cluster manager and requests for those things. Parallelly, it creates the DAG. DAG is the directed acyclic graph. It creates the DAG for the executors. How your code is like which executor is going to perform or how your code is actually going to be executed there. This was all about driver node mechanism. So this all of these activities were performed inside the driver node only. This all designing process, this all your optimizations, converting your unresolved to logical plan and deciding how many cores, executors you and RAM, memory, CPUs you actually needed. This all is decided, this all designing process, all is done in driver node as well as DAG creation. So we will understand more for the DAG because there are multiple steps inside the DAG as well. So this all is covered under the driver node. That is why this is called the brain of the Spark. So let's understand. This is the final code submitted by you or not by you, actually by the driver node or your catalyst optimizer to the Spark context that this needs to be executed. Now, Spark context will create the tag, a graphical representation of your uh, uh, it will create basically the graphical representations of your code for the Spark or for the executors. So let's see what are the steps involved here. First, what all actions does it have? How many actions? Actions are the uh, see we there are multiple operations covered under the one code. Reading the files, joining the files, filtering the data, and writing it at another locations, or showing the count or printing the count of that data what we have joined with the other files and all. So this was a very basic example or very simple examples we can see. There are basically reading, joining. They are basically reading, joining, filtering, writing, and printing the count. These all five kind of operations. But all of these five kind of operations are divided under multiple categories from the Spark context side. Reading the file is called the creating the data frame, while writing the file at certain locations and printing the count are called the actions. This is what executors or the Spark or the cluster actually has to perform it. So it identifies how many actions are given or how many actions are written in your code. Based on that, it decides how many jobs will be there. So you see, writing, printing the count, showing the data frame, displaying the data frame, this all comes under the actions item. I will give you the list of these all, what all are actions, what all are the stages and all of these things, so you can understand it in better way. So let's understand here in a very simple way. Writing data frame and getting the count, printing the count is called your actions, and those are the two jobs. While C, there are some other operations, filtering the data, joining the files, or reading the files. This all the things. So this all are called the stages of the code. What all stages does it have to pass? Filtering the files and joining the files. Once we have all of this data, now you know while you are filtering the data or joining the files, there will be certain data involved there, and data is written into partition format. So how many partitions of the files will get impacted, or how they will get shuffled, or how their data will actually get moved from one partition to another partition. So once we have this already, that what all stages, what all tasks, what all jobs we have available, there will be task scheduler. Task scheduler means task is the actual work to be done, that what all executors are going to pick which container and how they're going to perform. Then it comes into the picture task scheduler, and this task scheduler submits its code or this plan to the worker node, whatever the worker or the executors we have received from the cluster manager. So cluster manager basically, you have seen in our past slides that Spark Context connects with this cluster manager as well as creates the DAG at the same time. So when it was creating the DAG, in the meantime, cluster manager has provided you certain executors, or it is registered with driver node, that you can use this nodes, you can use these executors. So those executors will get work from this task scheduler. So this all of this planning, all of this assignment of the work, all of this is done inside the driver node itself. So you have seen what all work driver node basically do. Not only getting the requirement and giving away the giving back the results. It's not only the work of driver. Why this works this much a lot? Catalyst optimizer, Spark session, Spark context, DAC creation, task scheduler, submitting the code to the worker node, and parallelly meanwhile connecting with the cluster manager to get the uh, clusters available resources. So this all work is done inside the driver node. So after once we have task available with the task scheduler, it will submit its code to the worker node. Now we will see how the worker node behaves, or what all actions are actually, what all actions are performed inside the worker node. So as soon as the tasks are submitted to the worker node, those tasks are divided among executors, and in the name of task, in the form of task, right? So worker node can have multiple executors, and one executor can perform multiple tasks. We can see here, right? So one executor is performing two tasks on two partitions, basically on two container of data, and another executor 2 is performing task 3 and task 4 on another container of data or another partitions of data. So worker node has received the list of tasks what needs to be executed, it divides among executors and executors perform the task. These are the executors which perform the actually task upon the uh, on the top of your partitions or on the top of your data partitions. Once everything is calculated, all of this data is all of these results are given back to the driver node. Driver node then aggregates those results and send back to the application or the client. So this was all about Spark internal working mechanism, how tasks are scheduled, how they are optimized, or how the logical plan and the best physical plan is created, DAG is created. Everything is what we have covered in this sessions. So now we will understand this in more by real-time example. So in this real-time examples, we can see this is the sample code submitted by a client, and this is called the applications. So basically there are four parts into this code: reading the file, filtering the data, group by the data based on some columns, and displaying this. Once driver node receives this, it optimizes the plan, it creates the best physical plan, and once that is ready, it creates the DAG. DAG. DAG is the directed acyclic graph. Read, filter, group by, display. So this is the DAG created by the driver node. Once DAG is ready, it will create the stages. Stages means see. Stage 1. So we have seen in our previous slides that what all the transformations we have, it will create the stages based on that. So we can see reading and filtering. This all two actions or this all two code or line execution is done under one stage. As soon as it comes to the group by logic, we can see there will be shuffling of data and new task will be created, new stage will be created for that. So there will be two stages for this piece of code or for this applications. So number of stages will be there, two. There will be one action item. One action item is what? Show, displaying the data. Number of jobs, number of application actions will be one, while number of stages will be two. How it, one is for filter and one is for your group by. Now see the task. Suppose there are 8 partitions of data. So on each stage we are working for all of this data, like we are considering all of this data sets. So there will be 8 partitions and number of partition is equal to the number of tasks. So we can see there are 8 partitions, means 8 tasks will be there. So 8 tasks on each stage. There will be total 16 tasks for this DAG or for this Spark applications. So you just have to understand how many stages, jobs and tasks included for this. Number of job actions is number of job is 1, that is the show or displaying the data. Number of stages is 2, stage 1 at filter, stage 2 at group by, while number of tasks is the 16, 8 per stages, 8 for this stage and 8 for this stage 1 and stage 2. This is the task creation. Now let's understand what all this, so how this actually work. As soon as this one first line of code is executed, it will read the data frame. On second line, that will be stage 2. For third line of the code, there will be stage 2. Sorry, for second line of the code will be stage 1, while for the third line of the code will be stage 2 created. And final line of the code is called the action item or job action creates. And as soon as this action is called, all of this 3 line of code will get executed. Until and unless you does not call any action, it just sit idle. It does not perform any of this action. Spark does not. That is called the lazy evaluation phenomena. So this was all about Spark internal working mechanism. How does it work? How your code flows from while you submit from driver, cluster manager, and worker node. So what is the flow of that? What is the tag? What is the lazy evaluations? And calculating the number of stages, actions, and tasks. All of this we have learned in these sessions.